Hello, fifth grade. We're going to go ahead and get started on Science 8.3, which is all about on page 215 through 220, and it is the atmosphere and the cloud factory. Okay, so interesting thing about clouds. Okay, we look up in the sky, and to be honest, you would probably think they don't weigh very much because it's just a cloud floating in the sky, right? Well, guess what? That's actually not the case. Clouds can weigh 1,000 tons. Okay, do the math for a minute. How much is in 1 ton? 2,000 pounds. That would give us 2 million pounds heavy is what a cloud could weigh. Pretty crazy, right? I mean, it's just floating up there in the sky. But that is how heavy a cloud actually can be, okay? So now, clouds are not actually made up of water vapor because water vapor is an invisible gas, okay? But clouds are made up of tiny little water droplets, okay? And it takes 1 million tiny little water droplets to make one raindrop coming out of the sky. Now, think about all the raindrops and all the little tiny water droplets that are floating up in the sky, and now you could see how heavy a cloud could really be, right? Okay, so now we know that the sun warms the earth, right? And we know that then the earth warms the air as the heat radiates off of the earth, okay? And as the air moves away from the earth, okay, because remember, warm air rises and the cool air comes in and is pushing the warm air up and away from the earth, okay, then that forces the warmer air to rise. And as the warmer air rises, it becomes cooler as it's floating away from the Earth's surface. And as it goes higher and higher, it ends up going higher and higher out into our troposphere, right? And we know that our troposphere is where weather comes from, okay? Because this is the area in the troposphere of our layers of the atmosphere where all of the weather takes place, okay? So as that cool air is rising in the air, so now it's funny because we say, wait a minute, you just said that warm air rises. Yes, warm air rises, okay? But the cool air is actually pushing it up and away, and then as that warm air is rising, it eventually ends up getting colder and colder, okay? That's why we need to have protective gear when we go up higher in altitudes because it gets colder and colder, and that's also why we have problems with going up into the troposphere part of our layers of atmosphere, like in planes, and you could see a lot of how cold, like if you ever touch the side glass, right, of the airplane, you'll feel how cold it is, right, because that cold air is getting colder and colder as it rises through our troposphere. Okay, now imagine, here we go. I mean, these are all these things that God's putting together to make things work for our earth, okay? So as that air is escaping out into our troposphere, it gets to a point where it actually hits a tropopause. You know, it sounds fun, a tropopause. And that is a part where then the okay, wait, I gotta get my notes. Hold on. That's which usually the temperature in that tropopause, okay, is between 60 and 80 degrees below zero, okay? Remember, like cold is 32 degrees Fahrenheit, like below zero. Okay, we're getting colder, 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 colder. Okay, so that's pretty cold, right? So as that happens and that we get to this point called the tropopause, okay, what ends up happening is the temperature ends up changing directions, okay? Hear what I'm saying? That actually is because it reverses in direction, okay? Because remember, I told you that the troposphere is closer to the Earth, but remember I told you out in stratosphere and the mesosphere and the exosphere, things are getting hot, hot, hot up there, okay? So that's where the tropopause actually holds the temperature at the earth, okay, where this is a certain temperature and then it starts reverting and now out here it starts getting hot, Okay, so it's a reverse, and that is called the temperature inversion, okay, where it inverts and it starts going the opposite direction, okay? And it's interesting because this is where the weather brews, and then after that point, that's where, remember, it said no weather goes into that other part of the atmosphere. Only weather is in our troposphere, okay? And we know that as we get out into the stratosphere, the reason why we know things are getting hotter and the air is changing is because of stars and the gas that they're producing, and also the sun and the gas that it is. And we also know that because we have things that are burning up in space, and we know that once we sent our spaceships into outer space and things, they had to have such a protective gear because they got to a certain point, it was so hot that they would melt, okay? So now we have our three main ingredients for our cloud. So, okay, so remember, as the heat is rising off of, okay, so the air is rising off of the planet. I'm going to move this over a little bit. Okay, so as the heat is, the sun is heating the earth, and then the heat is rising up off of the earth's surface, okay, so the air is rising, okay, and the cold air is coming in and pushing the air rising up, okay, we're ending up getting our weather, okay, in the troposphere. Now that's where we have our cloud formations, okay, so we have to have three parts to have a cloud, okay, three ingredients. We have to have water, rising air, and dirt, okay? So let me tell you about those. Now, we get water through the evaporation process in our water cycle, okay? And remember that when the warm air is able to hold more water vapor than cold air, okay? And that's why the warm air is located in the troposphere, and we have a great deal of water vapor giving us our weather in this layer of the atmosphere, because we have our warm air holding the water vapor in as it's going up into the air, okay? Now, then we have rising air, okay? So we have our water, okay, that we need for our cloud, and now we have our rising air. Now, as the warm air is rising, it's actually taking the water vapor with it, okay? But remember, warm air holds more water than cooler air. So as that warm air is rising, what's happening to it? It's cooling down, right? So as it's cooling down, it can't hold as much water. Remember, we talked about this already? Okay. So as it's going up, right, and it's getting cooler and cooler, then the maximum amount of water that the air can hold ends up getting to its dew point, remember? And it becomes saturated, 100% saturation, meaning that the air can't hold any more water vapor, okay? Can't hold it. So when it can't hold the water vapor, what ends up happening? It ends up condensating, right? And as it condensates, it's got to go somewhere, and it's got to form a cloud. But when it condensates, it actually needs the third ingredient, okay? The third ingredient is the only way that the cloud can actually form. The third and final step, it's the most important, and that is dirt, okay? So now, as the water vapor condensates, it needs a solid object for the water molecules to collect on and to form liquid, okay? Like the side of the glass or on your car, remember when we said the temperature changing, or like the side of the glass, I told you to do that, go out in the sun and stick that nice cold glass of ice water in the sun yesterday or today, right? And then all the little water droplets start. Well, those water droplets are forming on what? The side of the glass, right? Well, guess what? There's not a whole bunch of glasses floating around in the sky, is there? No, there isn't. So it's got to be able to adhere, meaning the molecules have to attach to something floating in the air, okay? Now, in the air, there are tons of little tiny, very microscopic particles of dust floating in the air. So Let me tell you, yeah, we're kind of like breathing in and eating dirt all the time, okay? It's teeny, 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 tiny, okay? So we don't notice them unless sometimes, have you ever seen when the sun shines through, like through the window, and you can see that little layer of sun and you look across and you can see the little floating specks in the air? Guess what? That's dirt, friends. It really is, okay? So that's where we have dirt, okay? So all of those little teeny tiny water droplets that are starting to form into liquid because the rising air is now getting cooler and it's starting to condensate. Those little teeny water droplets have to adhere to the dirt, okay, so that they can actually form a cloud. So now that's how the cloud is actually formed, okay, because all of the teeny tiny little water droplets are now floating around in the sky. Now you're asking, but how come they're floating around in the sky? Things that are heavy end up falling to the ground, right? Gravity. You're absolutely right. But these are so teeny and so small. Remember, 1 million of them only make up one water drop. So all that little white that we see in the sky from the cloud is actually teeny, 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 tiny little particles of dust with little teeny, tiny water vapor on them, and that's forming the cloud. Okay, so as we go through the earth, we have, remember, the different parts of the earth that end up having the different wind patterns. Okay, so the tropics will have more warmer air, right? Causing more clouds and also causing a rainier weather in those areas because the warmer air has more water vapor, right? That's why tropics have that tropical feel of having that sticky humidity. Remember we talked about yesterday, but also they have more rain, and that's why they have more lush, beautiful green plants and tropical forests, unlike here on California in the desert, right? Okay. Now, mountains, that's another thing about mountains. Mountains can become an obstacle for wind, and that's why when the air is moving over a mountain, it can actually stop, and then you could actually see a cloud forming around the mountain because that cold air stops and it starts to release some of the water vapor and forming a cloud. And that's why we sometimes, if you look up at the mountains, you can see like that white fog at the tops of mountaintops. That is the cloud forming because the air can't push that cold water, or that cold air, the wind can't push the cold air across. Okay, so moving on to my last part, and that is the prevailing, the polar easterlies, prevailing westerlies, and the trade winds. Now, depending on where the winds are pushing, okay, we end up having the 3 wind belts, and this has such a constant change of weather that it results in the jolting and the mixing of huge masses of warm tropical air and also polar cold air, okay? And because of those huge masses of air, we end up having source regions, okay? And those source regions are when the air ends up taking the same temperature as the ground in these big areas, and we have what we call an air mass. And you have different types of air masses. There's like a continental air mass, a maritime air mass, tropical air mass, a maritime polar air mass, continental polar, and an Arctic Arctic and Antarctic air mass, okay? Now, the boundary and sometimes between those air masses is called a front, and you've ever heard people say like a cold front or a warm front. Well, that just is, at the warm front, the warm air pushes back cold air, but the cold front, the cold air pushes back the warm air. So that's where you get cold fronts. So anyway, these are really your 3 notes you need to know about the ingredients for this, and I hope this explains, but I have to end this or YouTube will not let me put it up because I'm going to be over my 15 minutes. So I hope you guys understand. If you have questions, let me know. But this was our science section for today, and let me know if you have questions.